A silent alert ripples across the world's observatories. A massive interstellar object, 3I Atlas, is inbound. It's 3 to 5 kilometers wide, heavier than anything we've ever seen from another star, and the UN Space Committee has just rushed it onto their agenda. For the first time, world space agencies aren't just studying a visitor, they're coordinating policy and rapid mission planning before it's gone forever. The UN's Committee on the Peaceful Uses of Outer Space has moved the 3I Atlas briefing to the top of its schedule. Space agencies are scrambling. This isn't another Oumuamua that was small, tumbling, gone before we could blink. This is Borisov either. That was a typical icy comet, predictable and normal. 3I Atlas is something else entirely. It's 3 to 5 times more massive than both of them combined, 33 billion tons of material from another solar system barreling through ours right now. The Atlas Survey telescope in Chile caught it on July 1st. Within hours, astronomers knew something was off. The orbit was hyperbolic, which means one thing: it's not from here, it came from another star system and it's not staying. Recovery images pushed the timeline back to mid-June. We had weeks of warning, not years. NASA's Hubble Space Telescope locked onto it July 21st. The images showed a solid nucleus wrapped in a teardrop-shaped dust cocoon, a faint tail streaming behind. It looked like a comet, but the numbers didn't add up. James Webb joined in on August 6, turning its infrared eye onto the object. The spectrograph readings came back fast. Carbon dioxide dominated the signature far more than any normal comet. Water was there, but barely. The ratio was off by a factor most scientists had never seen. Then the global mobilization began, not just NASA, not just ESA. Every major space telescope on and off Earth pivoted toward 3I Atlas. SPHEREX, TESS, SWIFT, the Mars Reconnaissance Orbiter, Curiosity, Perseverance, even planetary spacecraft billions of miles away were tasked with opportunistic observations. ESA's Mars Express and ExoMars Trace Gas Orbiter prepared for an October 3rd flyby. The Jupiter Icy Moons Explorer would track it through November. Ground observatories in Hawaii, Chile, and Australia worked around the clock. Gemini South, the Very Large Telescope, and the new Vera Rubin Observatory, all eyes on one target. This level of coordination is unprecedented for a comet, but agencies aren't calling it just a comet anymore. Internal memos refer to it as an ISO, an interstellar object. That changes everything, because here's what nobody talks about: we have no protocols for this. The UN's asteroid warning network was built for rocks bound to our sun, objects we can track for years, even decades. 3I Atlas came in at 26 kilometers per second on a trajectory we spotted only months before perihelion. Our planetary defense playbook doesn't cover hyperbolic visitors. Astrophysicist Avi Loeb saw the gap immediately. He and his team drafted a white paper proposing a United Nations Committee on Interstellar Objects, a formal framework to coordinate detection, observation, and response planning. They even suggested a classification scale from 0 to 10, ranging from ordinary comets to confirmed artificial objects. The proposals landed on desks in Vienna, where the UN Space Committee meets, and suddenly 3I Atlas wasn't just a scientific curiosity, it became a test case for global space policy. The clock is ticking. 3I Atlas will reach its closest point to the Sun on October 30th, just 1.4 astronomical units out, barely inside Mars' orbit. After that, it swings back outward past Jupiter in March 2026, then gone forever. No second chances, no do-overs. Mission planners are running the numbers. Could we reach it? Redirect a probe. ESA's Comet Interceptor mission is still in development. NASA's interstellar probe concepts exist only on paper, but launch windows close fast. If anyone wanted to send hardware to meet 3I Atlas, they'd need to act within 2 to 3 years maximum. That window is closing, and the data coming back is only getting stranger. Why this comet? We've seen interstellar objects before: Oumuamua in 2017, small and strange. Borisov in 2019, normal and icy. But 3I Atlas is bigger and stranger, and we have only a short window before it disappears beyond reach forever. This isn't just another science story. What's happening now could shape how humanity responds to any future visitor, natural or not. If a rock from another star system were headed toward the Sun right now, how fast could Earth react? We have asteroid plans, impact assessments, deflection missions, but for hyperbolic objects like this, the playbook is thin. That's exactly why 3I Atlas is causing such a scramble. Webb and Hubble sent back their data in August. The nucleus measures 3 to 5 kilometers across 33 billion tons of mass. That's confirmed. But here's what doesn't make sense: almost no non-gravitational acceleration. For a comet this size, you'd expect strong outgassing jets pushing it off course, volatile ices erupting from the surface, creating thrust. But it glides with eerie steadiness, like it's locked on rails. Scientists ran the models twice, then three times the numbers held. This thing is moving like a rock, not a comet, yet the dust cocoon proves it's outgassing. Something about its structure is different. Then there's the chemistry. Carbon dioxide dominates the spectral signature that's rare in our comets. Most are water ice with some carbon monoxide mixed in. 3I Atlas flips that ratio. CO2 is the primary volatile, water barely registers. And there's something else in the spectrum, atomic nickel. Not a lot, but it's there. Spectroscopists flagged it immediately because nickel usually travels with iron. They're chemically bound in most cosmic environments. But 3I Atlas shows nickel without iron. That's a formation fingerprint unlike anything in our solar system. This is a pristine fragment from another star's frozen edge, an untouched time capsule. The chemistry tells us it formed in conditions we've never directly observed, maybe deep in another system's equivalent of our Kuiper belt, maybe somewhere even colder. The mission clock is ticking. Perihelion hits October 30th, 2025, 1.4 astronomical units from the Sun just inside Mars' orbit. After that, it accelerates outward. Miss the next 18 months and it's gone forever. No probe could catch it, no telescope could track it. So why is the UN suddenly paying attention? Because our current planetary defense network was built for slow, bound asteroids, objects with predictable orbits we can track for years, not fast strangers from deep space. The International Asteroid Warning Network, IAWN, launched in 2014, coordinates global detection efforts. The Space Mission Planning Advisory Group handles deflection missions. These systems work brilliantly for near-Earth asteroids. We get years of warning, time to plan, time to act. 3I Atlas was discovered only months before closest approach, July 1st to October 30th, 4 months. That's it. If this had been on a collision course, we'd have had almost no time to respond, zero margin for error. Avi Loeb saw the problem instantly. He drafted proposals with his team at Harvard for a new framework. The United Nations Committee on Interstellar Objects UNCO, a dedicated body to handle visitors from beyond our solar system. The proposal includes the LOE scale from 0 to 10. 0 means ordinary comet, 5 means unusual but natural, 10 means confirmed artificial object. The scale gives us a common language, a way to classify and respond without panic or confusion. For the first time, these papers aren't theoretical. 3I/Atlas is making them urgent agenda items. Delegates in Vienna are actually reading them. Discussions are happening behind closed doors, not about aliens, but about readiness. Some delegates want global early warning treaties for interstellar objects. That doesn't mean aliens. It means clear data sharing, mission coordination, and public alerts before something fast and unknown slips past us again. Right now, there's no legal framework, no treaty. If a private company detected an ISO first, they wouldn't be obligated to share data. If one nation wanted to send a probe and another objected, there's no process to resolve it. 3I Atlas is exposing every gap in our system. NASA has concepts on the drawing board, Interstellar Probe, a mission designed to chase objects like this. Fast launch High Delta V built to intercept hyperbolic visitors before they escape. It's still in the planning stages with no hardware yet. ESA has something closer to reality, Comet Interceptor, a spacecraft designed to wait in orbit until a pristine comet appears, then launch fast, reach the target, and gather data up close. It's scheduled for the late 2020s, but here, the problem: to intercept 3I Atlas, a probe would need to launch within 2 to 3 years maximum. The math is brutal. Every month of delay adds exponentially more fuel requirements. Miss the window and no amount of rocket power can catch it. Engineers are running simulations right now, launch dates, trajectory options, fuel loads. The numbers are tight, possible but tight. And that assumes funding gets approved immediately, that the spacecraft is built on an accelerated timeline, and that nothing goes wrong.